Welcome to My Project Bazaar. Our project title is Academic Performance Prediction Using Machine Learning Approaches, a survey. Next, abstract of our project. The accurate and early prediction of student academic performance is the cornerstone of modern education systems, enabling timely intervention, personalized learning pathways, and improved resource allocation. This survey paper provides a comprehensive analysis of the application of machine learning (ML) approaches for predicting student performance. We systematically explore the diverse landscapes of predictive modeling in education, reviewing a wide array of algorithms from traditional models like decision tree and Navy Bayes to sophisticated ensemble methods and deep learning architectures. The paper investigates the critical role of feature engineering, categorizing and evaluating key predictive features such as demographic data, previous academic records, student engagement metrics from learning management systems (LMS) and behavioral. Furthermore, this survey delves into the various education contexts where these models are applied and higher education. We also address significant challenges within the field, including issues of model interpretability, data privacy, ethical considerations regarding algorithmic bias, and the problem of model generalizability across different institutional contexts. By synthesizing findings from recent literature, this paper aims to serve as a valuable resource for researchers, educators, and practitioners, outlining current trends, highlighting successful methodologies, and identifying promising future directions for leveraging machine learning to enhance educational outcomes and support student success. Next, objectives of our project: to systematically review and categorize the predominant machine learning algorithms and models employed for predicting student academic performance, to identify and analyze the key data sources and feature types, example, demographic, academic, engagement, behavioral, that are most predictive of student outcomes, to evaluate the challenges and limitations associated with current prediction models, including issues of data privacy, model interpretability, algorithmic bias, and generalizability across different educational contexts. To access the practical implementation of these predictive systems and their impact on supporting teaching and learning processes, such as through early warning systems and personalized interventions, to compare the performance metrics used to gauge the effectiveness of different models and identify the most robust evaluation frameworks for this domain, to identify emerging trends and future research directions for advancing the field of educational data mining and learning analytics. Next, flow of our project. So here, first, there is an batch monitoring process. In batch monitoring process, we give the input methods like uploading CSV file and generate sample data. Based on that, we have the process batch data, run batch predictions, display summary and detailed results. So from this batch monitoring process, we have the batch monitoring block separately. From the batch monitoring, we have main dashboard. So from this main dashboard block, we have the subdivisions like intervention tracking, real-time monitoring, analytics dashboard, individual prediction, then update all dashboard. From this batch monitoring process, we have saved those histories separately, and those histories has been used to update all dashboards. So next, from the intervention tracking, we have the separate block. We have record new intervention, track intervention status, then schedule follow-ups. In the real-time monitoring, we have simulate live data, monitor activity metrics, generate live alerts. Then in the analytic dashboard, we have retrieve history data, generate trends and visualizations, calculate performance metrics. So finally, in the individual prediction process, we have the input student data, slider and forms, run predictive algorithms, display results and risk analysis, finally generate recommendations. So additionally, in the main dashboard, we have the user authentications like login and registration. Then only the student performance prediction system will start. So finally, then log out. That is the end of the project. So this is our web application for student prediction system. So here first we need to go to registration. So I'm going to register with the full name as it is username, email, password, and same password for confirm password. So create. So we need to give these 6 characters. So create account. So account has been created successfully. So login with the same username and password. Click login. So this is our main page. So here the profile details and login button has been placed. Then here we have the navigation drop downs. So this is the prediction part. So we need to give the academic information like some data. We can give the new data for the prediction. After that, click predict performance. So the model will predict the result. So first, pass probability and overall scores, risk level and prediction. So for these input students, the risk level is low risk. So finally, the probability breakdowns has been plotted in the bar plots. Then the model will provide the recommendations for the concerned student and feature impact analysis. So next, batch monitoring page. So here we need to upload the CSV file. So I'm going to upload the OULAD preprocessed data. So for this, the model will predict the batch performance here. So we have given the 32,593 students records. So the model will give the batch summary here as total students, high risk, medium risk and low risk, then risk distribution, pass probability distribution, then detailed result as CSV. So we can able to download the results as CSV. So if I click the download results as CSV, the model has been downloaded in our local space. So next, this is the generate sample. So if I give the number of sample students and click the generate and predict sample data, the model will predict those details. So here also we have the download results as CSV. So after the batch monitoring, we have the analytic dashboard. So this is the dashboard of first time range. We have selected for last 24 hours. So we have total predictions count, average pass probability, high risk students count, average academic scores, then pass probability trends and academic score distributions. So next we have the real-time monitoring. So I can able to enable monitoring for the alert threshold for refresh interval, the active students are 93 and new logins has been 16. At risk detection was 6 and system load was 46.2%. So the model will give the high number of at-risk students detection was 6. Next, live system activities has been displayed in this plotting. So if I change the refresh timings, the graph and those scores has been differed. So here the active students range will be 96 students. So next we have the intervention tracker. So here we can able to give the student ID and note, and we can record this intervention. So it can be stored as a record. So after that we can able to view the model performance. For our model performance, the classification metrics has been accuracy, precision, recall and F1 score. Those values has been displayed here. Then performance trends plot has been displayed here. Then feature importance plots. Finally, the system info has been displayed here. So first system overview, then model information based on prediction methods and key features used, then system statistics, then user instructions. So we have 3 more instructions. Finally, this is the system control like clear history. So if I click the clear history, the total prediction made has been deleted. So everything has been deleted. Then before that we can able to export the session data. So download, so it has been downloaded in the JSON file. So then this is the logout button. It will automatically move to the login page. Thank you.